and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel Foundation Tier paper from 2019. This is paper 2, and we're on question 14. We're covering all the questions, so if you find this helpful, please subscribe to our channel. So this one is a ratio, and we've got the ratio 4.5 to 2.25, and we've got to rewrite it in the form n to 1. So what we need to do is we need to change the 2.25 into a 1, and we can do that by dividing 2.25 by itself. So divide 2.25 by itself, that will give us 1. And because we've divided one side of the ratio there, we've got to do exactly the same thing to the other side. We've got to divide the 4.5 by 2.25 as well. And I might as well do that on the calculator. So if I do that, 4.5 divided by 2.25, and I get 2 as my answer. So there we go, that's the ratio in the form n to 1 is 2 to 1. We're now looking at question 15. What we've got is a garden in the shape of a rectangle, so it's 90 meters by 60 meters. And we're told that flowers are grown in 40% of the garden and the rest of the garden's grass. So we've got to find out what the area of the garden is that's grass. So the first thing I would do is find the area of the garden. So area of the garden, and that's just going to be the length, if this is our length, multiplied by our width, because it's a rectangle. So I'll just call that L times W for length and width. And if I put the numbers in, then what I'm going to get is 90 times 60. And again, because this is a calculator paper, what we'll do is we'll just do this on the calculator. So 90 times 60. And what we get is 5,400. And that's going to be meters squared. So we're in square units because it's an area. And so we just need to find out what the area is that's grass. Now, if we've got 40% of the garden is flowers, then we would get the remaining part is grass. And so since percentages add up to 100, the whole area would be 100%. Then if 40% is flowers, that would mean that 60% would be left as grass because they add up to 100. And so what we need to find out then is what 60% of the 5,400 is. So to do that, again, what the easiest way actually is to convert this percentage into a decimal first of all. So I'm going to do that by moving the decimal point 2 places to the left, and I get 0.6. So I've converted this percentage into a decimal, and it's 0.6. And I just changed that to a multiply, and that's 5,400. And so if I do this on the calculator, just move that over there so it's not blocking what I'm writing, then I can just go 0.6 times 5,400. And there we go. We get that that's 3,240. 240 meters squared. We now look at question 16. Then this is a question about probability. So we've got 4 biased coins A, B, C, and D. And so we've got different probabilities that each of the coins will land on heads. And those probabilities are shown here. And what we've got to do is work out which coin is the least likely to land on heads. So we need to really convert all of these numbers into decimals. So we've got to change to decimal. And then once they are decimals, we can compare them. So we can say But 0.33, we don't need to change that one, and 0.033. But we've got this 1/3, and we can change that into a decimal by dividing the top by the bottom. And because I'm on the calculator paper, then I'm going to do it on the calculator. So I've got 1 divided by 3, and so that's going to give me 1/3 on this calculator. So it might look like we've made no progress there, but what I'm going to do is use this SD button, and that will give it me as a decimal. So we can see it's actually 0.3 recurring, which just means the 3's would go on forever. So this one, 0.33, I'll just write a load of 3's, but I could actually say that that was 0.3 with a little dot above it. And that dot there means that the 3's carry on forever. And next of all, we've got this 30%, and we need to change that into a decimal again. And we can change decimal into a percentage by taking our number as a decimal and just moving the decimal point 2 places to the left. So we can see there, since it's 30, we put the decimal point after the ones column, the units column, move it back 2 places, the decimal point would actually go to there. So what that means is we've got 0.3. I don't really need to write the 0 after the 3 there. So just 0.3 is what I've got. So this is what I'm comparing. And so which one of these is the smallest number? And it's actually this one. Because if we look at the first column after the decimal point, we can see this one here has 3/10. This one has no tenths at all. This one's got 3/10, and this one's got 3/10, a 3 in the tenths column. So it must be this one, which is coin B, that has the least likelihood of landing on heads. So I'll write down a B for that one. Which coin is most likely to land on heads? Well, we need to compare the remaining 3 decimals. So we've got, I'm just writing them again. So we've got 0.33. We've got, I'm going to ignore this one here because that was the smallest anyway. So we've got 0.33 with a load of 3's after it going on forever, which is the recurring one. And we've got just 0.3. So which one is the biggest of these? Well, we've got, if we look at the tenths column, we've all got 3/10. So that's the first column. So up to that point, they're all the same. If we look at the next column now, which is the hundredths column, and we've got a 3 in that column, a 3 in that column, but we don't have anything in the hundredths column there. So we can ignore this one then. So the choice of which one's the biggest is between this one and this one. And so I'm now going to look at the next column, and we can see the thousandths column. We don't have anything in that one, but we do have something in this one. We've got 3 thousandths. So this one then is the biggest, and that is C. So we can see that was the one that was 1/3. So it's C. So moving on with this question. So Julia says the probability that coin C will land on heads is the same as the probability that coin C will land on tails. Is she correct? Well, we might think that she was initially, because on an unbiased coin, then the probability of, write it like this, probability of heads is 0.5, and the probability of tails is 0.5, so it's equal, but that's only on an unbiased one. What we've got is a biased coin, and so if, as it says up there for coin C, probability of getting heads is, so the probability for coin C getting ahead was equal to 1/3. And since all the probabilities have to add up to 1, and we can see these would here, they would add to 1. So add to make 1. That would mean that the probability of getting a tail would have to be 2/3. And that's because 1/3 plus 2/3 would equal 1. And we can see then that she's not correct. So she isn't correct because actually the probability of getting a tail is 2/3. So because I might write it like this, probability of a tail equals 2/3. So which isn't the same as getting the heads. Look at the next part. It says coin B is going to be thrown 4,000 times. So we've got to write an estimate for the number of times coin B will land on heads. So we need to know what's the probability that coin B will land on heads. So I'm going to look back up at my table again. So the probability was 0.033. So that's the probability of getting ahead, equals 0.033. And we can get the number of times, or the estimate for the number of times, and that's called the expectation, which means the expected number of times something will happen. So the expectation for the number of heads, I might write it like this, expectation for the number of heads is actually the number of times that I'm going to throw it. So number of throws, and then we times that by the probability of getting a head. So times by the probability of a head. And so that would be 4,000, because that's the number of throws, times by the probability that we did get a head. And I'm going to do this on the calculator. So that was 0.033. So if I do that on the calculator, then we've got 4,000 times 4,000 times 0.033. So if we do that, we could expect that we might get 132 heads if we threw the coin 4,000 times. So it's an estimate. It's not guaranteed that we get that many, but that's just an estimate given the number of attempts and the probability. On question 17, we've got to work out the total number of calories in a breakfast that's made of bananas and yogurt. So what we're told is that there's 84 calories in 100 grams of banana and 87 calories in 100 grams of yogurt. So in our actual breakfast, we've got 60 grams of banana and 150 of yogurt. So what we would do is we'd start off with, say, 100 grams for the bananas. I'll just call it that, bananas, since I haven't got much space there, is equal to 84 calories. So I could then find out 10 grams and by dividing by 10. So in fact, I don't even need a calculator for that. If I want to divide by 10, then what I could do is I could just move the decimal point one place to the left. So that would mean I'd have 8.4 calories for 10 grams. And so if I need to work out what 60 grams is going to have in calories, and I just need to times that by 6. So I will do this one on the calculator. So move it over there so we can still see the calculation. I've got 8.4 times by 6, and we get that fraction, but we don't want it written like that, so we've just pressed this SD button, which most calculators have that on it. All the Casio calculators do anyway. So 50.4. So we've got 50.4 calories for the bananas, and for the yogurt, we know that 100 grams of yogurt is going to be equal to 87 calories. And we want to find 150 grams of yogurt. So I might just find 50 first of all, because 50 goes into 150. So once I've got 50, it's very easy to then find 150. So I could first of all get 50 by dividing by 2. So if I do that, let's just do that on the calculator. 87 divided by 2, and we press the SD button again, and we get 43.5 calories. And we actually want 150 grams. So 150 grams is, to go from 50 to 150, I need to times by 3. So let's times that answer by 3. And we get 130.5. So 130.5 calories. And so finally, all we need to do is we have to the total calories in the breakfast. So we just need to add these two figures together. Get the calculator up. I'm going to use the 130.5 that I've got there and just add 50.4 onto it. So plus 50.4. And again, I get it in that format. But what I'm going to do is just press the SD button there, and I've got 180.9 calories in total. So the total equals 180.9 calories. And oops, I didn't mean to cross that out. Let me just go back. Calories. There we go. So that's that question finished. So if you find that helpful, then I hope you will like our page and also consider subscribing to our channel. Thanks for watching.